So we were looking at some numeric data types, and we see that there are minimum and maximum values that some of these data types can hold. So I just wanted to kind of look at where these numbers are coming from. So let's take an integer, for example. An int has the ability to hold, it's going to take 4 bytes. So 4 bytes. So if you recall, when you learned about bits and bytes, 1 byte is equal to 8 bits. And we also know a bit can hold a value of 1 or 0. So a bit is going to be 0 or 1. It's going to be 1 byte. A byte is the equivalent of a character. And 8 bits, 8 of these zeros and 1, 801 combinations make up 1 byte. So a bit looks something like this. So some of them will be on, some of them will be off. And depending on which ones are on and off, that's going to convert to that can be converted to a character. Or this can be converted to a decimal number also. So there are 1, 2, 3, 4, 5, 6, 7, 8. And we read them from left to right. So let's look at, again, the integer, and it's going to have a range from about -2 billion. So let's keep this number in mind, -2,147,683,684. So 2,147,483,647. And that I may need to just make that a little larger so you can see it a little better. Okay, so I'm going to jump over to the calculator now. Let's see. Okay, so I'm on this Windows calculator and I need to change it to a programmer. So I'm going to change the mode to the programmer mode. And then we're going to enter that, we're actually going to enter 4 bytes because we said an integer is 4 bytes. So I'm going to just turn each byte on except for the first one. So that's 4, and I'm sorry, let me put this on binary. So let me clear it out, put it on binary. And now I'm going to enter, that's 4 bits. And we said 8 bits make a byte. So we turned on all 8 bits. So all 8 bits is the equivalent of 255. So if we look at 1 byte is 8 bits. 1 byte is 8 bits. We just turned on all 8 bits and we saw the equivalent of 255. So that's why a tiny int can hold numbers from 0 through 255. So that's how it kind of works behind the scenes. A small int is 2 bytes, and it's going to hold 32,767. So if I jump back over here and jump back over to my calculator and turn on 2 bytes, we should see that number. So, okay, so I have 1 byte turned on now. So I'm going to turn on 8 more. But I'm not going to actually turn on the last one. I'm going to leave that one off. Because this highest order one is reserved for the sign. Okay, so this is reserved for the sign. So we'll leave that one off. But when I click on decimal, the conversion, you can see there's that number 32,767. So 32,767, if you look in your book, you'll see that 32,767 is a small int, the highest number you can have in a small int. So that's how it's again, it's 2 bytes. So that's how that works. And I guess we'll do one more. So let's do the 4 int, the 4-bit, the 4 bytes. So we're going to turn on 4 bytes, which is an integer, 4 bytes. So we currently have 1, 2, 2. So let's turn that last, let's just start over. Clear them out. And we'll turn on 4. That's 1, 2. So we're turning on groups of 8s. 3. And I didn't want to turn on that very last one. So I'm going to do that again. 1, 2, 3, and so 1, 2, 3, and 4. Now again, we use the last one, or the highest order, for the sign. So if we convert this to decimal, you can see there's that number, 2,147,483,647. So I'll jump back over to my document camera, and you can see there's that number. So we don't have to do the 8-byte one, so you get the idea of where these ranges are coming from and how that's working internally. Okay, thank you for joining me.